Hello, welcome. In this video, we'll dive into Android testing using test-driven development, TDD as it's called. Testing your app is important to ensure your app does what it promised to do and performs well across devices and serve people with special needs as well. Test-driven development is a disciplined approach that helps you ensure your code is reliable to fulfill that promise from the start. We will focus on two essential types of tests here. First, we will deal with unit tests for validating individual components or units in isolation, and then we go to UI tests for verifying user interactions and interface behavior and accessibility behavior as well. With test-driven development, we define the behavior of our app through test first, then we implement the minimal logic to satisfy that behavior, then we can refactor safely. Whether you are new to testing or looking to sharpen your TDD skills, this hands-on guide will help you build better Android apps one test at a time. So let's get started. So we're going to build a simple fashion product app. So let's assume the main feature of this app is to load display fashion products, either from an API or a database. But first, we focus on the unit test to demonstrate how we think, structure, and test our code from the ground up. So by the end of this video, you will understand how TDD actually works in Android, and you also understand how to structure clean architecture and how to write proper unit tests, and how senior engineers think about building scalable systems. So if you have not subscribed, please do. Would you mind take a few seconds to do that if you find value in the content we share here? So let's continue. So as you can see here, I've already created a project, and this project here is called fashion product. So in this fashion product, I've committed that to Git already, and I recorded a video recently, a full video recently, where you can learn how to commit your projects to Git properly. So you can find it somewhere around this video, and I'll put that in the description box as well. So now that we've created our project, we've added all the readme and all the git ignore files. So, but even though we're not going to be interacting with the API in this, because we're going to mock everything. So here we start first with structuring our app. Before we write a single line of code, we need to think about our app architecture. If we jump straight into developing the UI or mapping the API calls, that will lead to tightly coupled untestable code in the long run, and by then when you have hundreds of thousands of lines of code, that will be a very serious work to do. So instead, we start with structuring our app so that we can easily test different parts of it in isolation. So what we do here, we go to our app folder here. So in this our app folder, we can create new packages. First of all, let's start with the data. Let's start with data. So data, we create a data package here. Then another one, we add a domain package as well. Then lastly, we add a presentation package. So if you check the Android documentation, you discover that we have the data layer, the domain layer, and the presentation layer. So now that we've represented them like this, so this is a test demonstration. So we're not building the full app here. So we will start with adding the domain. So here we create another package in the domain, which we are going to call the model. So then we can also add the repository package as well. So here we'll leave all our repositories. Then in the domain again, we have another package that we can call result, because since we're expecting data from our source, there is going to come with some results, either success, failure, loading, or blank, whatever. So now we have our use case. So here is our use cases, which is where we're going to actually start our unit testing from. So then in the presentation layer, we have two more packages here. We can call the first one is the state, because in our UI, we're going to also represent state that is returned from our use cases down from our repository and all that, and implementations. So now we have also finally our view model. And since we're not dealing with the UI yet, we will leave that out for now. Okay, so now we have set the structure of our app. So now once we start incrementally building, we will now know where things should live and where things should belong without any ambiguity. So now our business logic is independent and our code can be testable once we put them in the right folders. So, and our dependencies flow inwards because the presentation layer depends on the domain layer and the domain layer depends on the data layer. Okay, so this is the foundation of our clean architecture. Now that we've gotten that out of the way, we'll start by writing our test. So first of all, let's write our repository here. Let's call this our product repository, which is going to be an interface. You remember, right to the interface so that we don't expose our data configuration to the UI. So here we call this, let's call this product repository. So in our test here, we're not going to implement this repository yet. So we just fetch the data that we need, the function that fetch the data. So we say suspend function gets product like this. So this will take no parameter. Then we return a list of product. Okay, so now that we have created the we have not created the product yet. So now we can now create the product class. We can go to our model and add the product data class. It's going to be a data class that we'll call the product like that. Add that to Git. Then this is going to, our product is going to have an ID, right? So an ID of string type. Then our product is also going to have a name and it's going to be of string type. Once we start implementing, we start checking for nullability and all that. But right now, let's concentrate on the test now. So, and every product should have a price, okay? And it's going to be of string type. Then we'll have to check if we have this product in stock or not. So we say in stock, and that's going to be a boolean. Is either going to that we have it or we don't have it. We can now import that here. This is our repository class. Done. Okay, so we'll move to the next one. So what we'll do now is to write a failing test. So this test is going to check if the product was returned, and if not, it will fail. But because we have not implemented our repository, it's definitely going to fail, which is what TDD is all about. Write a failing test to check the functions or the classes. Then write the function or the class that is required and pass the test. Then you now refactor, make it better, like checking the nullability, data, proper data mapping and all that. Okay, what we'll do now is to go to our test class, the unit test. This Android test is actually for the UI test because it's the instrumented test that has dependencies. But now we're just testing the functions. In our test, we'll add another test here that we'll call that get product use case test. Get product use case test, like that. I think I missed something. I missed the T, the last T there. So let me rename this and add the T, refactor that. Okay. So now in this product use case test, now we're going to initialize the variables that we need. First of all, we need our get product use case, which we've not created, and part of the reason why our test will definitely fail. And also we need a repository as well. So here, but because we don't want to expose our actual data, even though we've created that repository class, we use it in our test, we're going to mock that, like use a fake repository using mock data. So now we say private late init var. We call this use case, and this use case is going to be our get product use case. Now the actual get product use case right here. So now that we have created our variable for the use case, so this use case is actually why our test is going to fail, because we've not created the actual class for that get product use case. So but we need another variable here, which is going to be our private late init val. This one, we'll call this one our fake repository because we don't want to test our repository directly. So we're going to use a fake product repository. So fake product repository. So this fake product repository, we have not created it yet. So let's run off and create that. So our fake product repository is going to also be part of our tests package here. So here we say new package, we create a new Kotlin class that we call our fake product repository, like that. Let's add that to Git. So now that we've created that, this is going to inherit from our actual product repository class, like that. So now it's going to request us to implement the members, which we will do humbly. So now we are going to return results, which is going to be a list of our products. But we need to create a variable here. Let's create a var here that we'll call result, and that result is going to be our app result, which we have not also created again. So now this app result is going to return a list of products. Okay, so now the app result dot success, which we have not all created. So let's finish that off and go and create that. So this is going to return an empty list like this. Okay, so just an empty list. Okay, let's go to our result. We have a result package here. So in our result package, we're going to add the sealed interface to return the error states of our application. So this is going to be, let's use an interface, then change that later. So this is going to be our app error. We'll add that to Git as well. So this is going to be a sealed interface, like that. So this is going to have a data object. Now data object is not going to take any parameter at this point. So this is going to be our network error. And our network error is going to return app error, like this. So then we have our server error, and this is going to return our app error. Then again, we'll have unknown, maybe something we couldn't explain happened. So let's just capture all of them because there are so many errors. Let's just capture that as unknown error, and this is going to return our app error, like that. Then we can also add another sealed interface here that we'll call, let's call this app result, which is what we use in our test. So this app result is going to be a sealed interface, and this is going to have a data class now, which is success, our happy path. Then with a generic type, then we'll have a variable that we'll call data, because our happy part will always return a data but of generic type, then return our app result of generic type as well. So now, so here we need to pass that type as well. So alt T. Okay, so now we also have our failure part, which we don't really like, but it's part of the process. So failure is equal to, we'll have a variable that we'll call error, and it's going to be of type app error, and it will return our app result, and this will pass nothing, like that. We have those two errors captured. We can now proceed with our test. Now we can use all these elements, and in our test now, okay, our fake repository, so in here we need to import that class. So you see everything is happy now. Here we're not just returning the list of products anymore. We are going to wrap that in our app result to make sure that we capture the state accordingly. Okay, so we need to change the return type of the base function, which is our product repository, because here initially we're returning just because we did not create that the list of products. Okay, so you see everything affects everything. So now everything is happy. Our product fake repository is here. We have that now. So here we have our fake repository. It doesn't complain anymore. So let's move further now. What we need to do next is to build our setup, because before we test our functions, we have some parameters that we need, like here these variables that we've created, the use case and the fake repository. For our test in in Kotlin, we use at before. So at before is to set up the test. So here the function is going to be set up to set up the variables that we need, actually, not the test. So now we call our fake repository and we set that to our fake repository class like this. Okay, our use case is going to take that fake repository, which is get product use case, take this off, then we pass our fake repository like this. Okay, so this will continue to give us error because we have not actually created this function. So now that we've set up, our setup looks good. So let's create the actual test. So the test, we use test at test, then we create the function. The function will be returns success when repository returns success. So our function should return success when repository actually returns success. Okay, so then we use run test. So this run test is for us to test for us to actually run a coroutine test, because you know our suspend function here, our function here, the repository is a suspend function which must be running in a coroutine. So for we to use run test, we have to add this coroutine dependency here. So if you go to the libs file, you will also discover we have added this test here and we have added the version up here. So you need to add that. You can find that in the description section, or you go to my GitHub, you'll find this repository there. Okay, it's public. So now that we've created that, we need to actually add some dummy products because we're not accessing, we don't even have our database yet or API. So we create some dummy product to test this function. So we say product equal to list of. So here we pass our product we've created before, and we pass the first one is the ID. Let's just call this one. Then we have shoes. Then this shoe should cost like £50. It's costing £50. And finally, we add if it's in stock or not. So this should be in stock and this should be true. So this variable now, let's make this a val because we're not going to change that. Okay. Now that we've created that, so we call our fake repository dot result, which returns the result, and here our app result dot success, because that's what this path is testing now. So then we pass the product. So if it's successful, the data is going to return is a list of our products. Then now we say var, we create another variable to return the actual result, which is equal to now our use case, which accesses our repository. Okay, so now we use assert equal to test if this function actually return what is expected. Assert equals, we need to import that. So here we're going to pass our app result dot success, then pass our product and also the result. Okay, so now if we run our test, now our test is definitely going to fail because it's now complaining that unresolved reference, which is our get product use case, which we don't actually have, and that is why our test failed. So now let's implement a minimal code for that get product use case to see if our test will pass. But before we do that, let's quickly commit this to our GitHub. So here we add failing test for get product use case for the success case, because that's what we're testing now, the happy path. Okay, so let's commit that. Yeah, commit anyway. We know there are errors, and so now we are all caught up. What we need to do is to create that get product use case. So, and we're going to add that in our use case package here. So now we say get product use case like that. Okay, so we add that to git, and this get product use case is going to take on parameter private var repository product repository. Okay, so down here we're going to create a suspend function, which is going to suspend operator function, which is going to invoke, and it was going to return our app result and return the list of products like this. So here in the body, we're going to return our repository.getProducts like that. So that is our get product use case. So if we import that here, you see everything looks clean now, no complaints again. Then if we test, what am I doing? You see all our tests passed. I don't even know if that was what I clicked, but the test passed. So it's just one test which passed. So you see, this is all TDD is all about. So now we have just written a simple test based on the functionality, the functional requirement that was given to us, and we're able to mock our repository. And now once we write that function, our test is going to pass. And the next thing is that once anybody changes this, maybe you're working in a large team as you have a new person join the team, and if there is a change on this test will fail, which will now tell you that something has been changed. So if this test fails and you're monitoring it in real time, you can track where the problem is easily than having a bunch of codes without test. Then when something fails, you have to like start sieving through hundreds of thousands or millions of lines of code, which will be a serious headache. So that is our get product, our first unit test done, which is our get product use case. So the next thing we can test now is we'll test a failure part, because we have just done the happy part and everything works and everybody is happy, which is always good and sweet. But sometimes things fail because of some reasons. The API you're querying might change something on there. If it's a third-party API, it might change, or even if it's an internal API, the team that handles that can change something and things will break. So now if you have the failure part, the app doesn't just crash on your own end. It will tell you that something, maybe network error or something have changed. So that is why we need to test both the happy part and the unhappy part. We're going to write another test here, which is going to be our test. We've set up every other thing. Then the function is going to be returns failure when repository returns failure. So if our repository returns failure, then our test should also return failure. Okay, so here we're going to use our run test again, and in our run test we call our fake repository dot result. So this result is going to be our app result dot failure, which we've created before. So now we call our app error dot network. Let's say it was a network error. Then we can now create our result variable to return the actual result equal to our use case like that. So now we assert equals and our app result dot failure. So our app error dot network error, because that's the one we are much interested in, then return the actual result. So now if we run this, it's expected to pass. So even our failure parts pass because we've already captured that error in our app errors here, which is our majorly network error and our network error and which one again? Server error. So we can test for each one of them so that we can actually return the right thing so that we can troubleshoot accordingly. So this is why TDD is a pain in the ass, because it takes a lot of time from you, but it's necessary because sometimes some pain are worth it. So this is actually important. So let's quickly commit that again. So here we call this, okay, let's first of all commit the get product use case, implement get product use case to satisfy success test. Okay, so we commit that, push that, and that's all fine. So let's commit the other one, which is we add failure for get product use case. Okay, I think that's a good one. So now we push that All right, now we've tested our first unit test and that was successful. So let's clap for ourselves. I know we can continue testing a lot of things, but that's just a glimpse, and to show you what you need to do, then you can take it off from there and test what is necessary so that your app will be robust. So now let's move to the presentation layer, which is our UI. We'll start with testing our view model before we go to the actual screen. Okay, so if you need to go and grab a coffee, go and come back. Let's continue. Hello, welcome back. So now we'll move to our presentation layer, and in our presentation layer we'll have to test the behavior of our view model. So we need to find out if our view model is actually returning the state and the data from our use case down to our repository. So first of all, what the view model outputs to the UI, to the screens, is the state. So that state comes with the data. So it's either it's successful, it's failed, or it can be loading sometimes. So we need to capture the state. So first of all, to start with, let's go to our state and add our product UI state. Okay, so in our product UI state, which is also going to be a sealed interface, but because we don't have that option here, we still go with our interface. So we say product UI state and we save that, add that to Git and add the seal here. So now in our product UI state, we are going to have different states. So it can be idle, that means nothing, there is no event coming from the screen. So the view model is going to be idle. You can't continue emitting data like that without any request. So here we capture that state. So our data object, we call this idle, and this idle is going to return our product UI state like this. So the next one, if it's not idle, maybe it's loading something, we call this loading, and this is going to return our product UI state. Then the next one is, if it's loading, then it eventually either it returns error, maybe you couldn't find the data I was looking, or it returns success. So let's capture that state as well. So success, this is going to be a class, because once it's success, it returns data which we were expecting. So here we create a variable which is going to be our products in this case, and here this is going to return a list of product like that. So, and this is going to return the product state as well. So down here, the last one is going to be, this is also going to be a data class. So our error state, because we don't just want it to tell us error without giving us some information. So here we have a message, and that message is going to be of type string to give us an inkling, maybe an error code, or if later we are going to determine what kind of error is going to be returned based on what happened. Okay, so now that we've created this, we've created our product UI state. Now we can now actually work on our view model. We're going to call this our product view model test like this. So first of all, we start with our variables. So private var late init var, then we collect our fake repository like that. Then we have our private late init var, our use case. Then we have private late init var. This is now going to be our view model, which we don't have. So this is going to be our product view model like that. Okay, so now we have all the parameters. Then we use that before again. So before, we have our function which we will call setup. Okay, so here we're going to call our fake product repository equals to the actual fake repository class. Then our use case is going to be assigned to the get product use case. Then we pass our fake repository. Then here we have our view model, which is going to be our product view model. Then we pass our use case. Okay, so now we're going to write the actual test, which is going to use a test, and the function is going to be emit. We need to emit loading, then success when use case succeeds. So we say emit loading, then success when use case succeeds. Okay, so now we assign that to our run test, and in our run test we're going to add our dummy products again, and we'll assign that to list of products and our product is going to take an ID of 1. Let's use our shoes again, and the price is going to be £50. Then it's going to be in stock. True. Okay, because we're testing the happy part. That means everything is working. Okay, so fake repository dot result will assign that to our app result dot success. Then we pass our product. Okay, so here our ViewModel dot fetch product, which is the function to fetch our product in our ViewModel, which we have not created, but we're assuming it's there. So now we call our sat equal and product UI state dot success. Then we pass our product. Then here we call our ViewModel dot UI state, which is the exposed UI state, but we don't have that yet, dot value. So all these are going to be complaining. We need to assert equals. Okay, so we import that, and that's fine. So if we still run this, it's going to fail, as we know. So it's going to fail because we don't have the view models yet. So let's quickly comment that again. Add failing view model test for success flow. Okay, commit that. Here we know there are errors, but let's keep going. So now we have committed that. We go back. So what we need to do is to implement the actual view model to make our test pass. So all these things are not entirely the best functions and the best ways to do them, but it's just to demonstrate. So that is why there is that refactor at the end of, once you write a failing test, you write the minimal code to make the test pass. Then you can refactor and make your function more optimized later. Okay, we're going to go to our view model and actually create a proper view model. So this view model, we're going to call it ProductViewModel. Okay, so now in our ProductViewModel is going to take some parameters, which is our private var, which is going to be our use case, private var get product use case, like this, and this is going to inherit from the actual view model class. Okay, so now in the body, we're going to first private var our private UI state equal to mutable state of flow, and here we pass our product UI state like that. Then we have our product UI state, which the initial state is going to be idle. Then here in our expose state, so UI state is going to return a StateFlow of type product UI state. Then we'll assign that to our private UI state like that. So now our state is exposed to the screens or the view, whatever you want to call it. So now we create the actual function to fetch the products. So here we call fetch products, and here we, in the body of the function, we use our view model scope. So our view model scope dot launch. So here the UI state dot value, we assign that to our product UI state dot loading. Okay, so because now something is happening, so now we create a var. Say when var result is equal to get product use case, then here let's return is product is app result dot success. I need to import that. So then we should return our UI state dot value equal to product UI state dot success. Then we pass our result dot data. Okay, or then the failure part is app result dot failure. We'll return our UI state dot value. We'll assign that to our product UI state dot error. Okay, then we give them a simple message to tell them that something went wrong. Okay, so now we have captured the success part and the failure part as well for our function. So if we go back to our product view model test, if we import our view model class, every other thing will smile. So now we are actually in the clear. typo in use case. All right, let's separate it for you so that you'll be happy. Okay, so now what are you still complaining of? Test function name setup should start with a lowercase. Okay, another blunder. Okay, that's fine. So everything is in the clear. If we run our test failed. Expected success, but the actual what it returned was loading. Okay, so as you can see, our test failed, and this is why it failed, because if we look at the error here, it says that we're expecting success, but it's actually returning idle, and here is why. So if we have a look at our view model here, we discover that our initial state is idle. When our test runs, before the coroutine here is started, our tests have completed. So that is why we get a failed result. To mitigate that, what we can do is either we add advance until idle here so that it will actually wait and see that that coroutine has finished before it completes the test. So now if we run our test again, our test is going to pass. So this is one way of doing it. There are so many ways of doing this. We can actually update our view model properly and initialize our view model here and call our fetch products. If we do this as well, if we run the test, our test is also going to pass. So either way, but since we are just concentrating on test, we will not do this just yet. We will just use the advanced until idle down here. Okay, so with advanced until idle, our coroutine will complete and check all the possible outcomes, which is either failed, idle, loading, or success. Okay, so now that we've confirmed the happy part for our view model, it's time to test the unhappy part, which is the failure part as well. Okay, so let's do that. So now we're going to test let's write another test here. So we can actually make this global, cut this and paste this here, because we'll still need that in our error test. So at test, we have our function which is going to be emit loading then error when use case fails. So emit, so we'll assign that to our run test. So here we're going to call our fake repository dot result, and we'll assign that to our app result dot failure, and here is our app error dot network error. Okay, so here we call our view model dot fetch products, and we add our advance until idle so that it doesn't fail again, so that you wait for the coroutine as dot equal. So here we pass our product UI state dot error, and here we say something went wrong. Okay, so you have to make sure that the same error you're testing for is the error result that we expect here. So something went wrong, there's a full stop on that, and add that. Then the actual is going to be our view model dot UI state dot value, like that. So let's run this and see if our test will pass. So our error test also passed as well. So we have captured our view model and both the happy part and the error part. And now that we've done that, this should mark the end of our unit test, our function test, or our class test, if you want to call it that. So now we are going to move forward to our UI test. But before that, let's commit this. So here we're going to call this implement ProductViewModel with loading and success handling. Okay, so we commit that and push. Then we also add failure test for ProductViewModel. Okay, commit that, push it, so that we're all caught up here. So now we can close all the tabs and our view model is tested. So now it's time for our UI test. Hello, welcome back. So now we're going to focus on our UI test. But before we do that, because we're trying to follow standard best practices in the industry and build production grade applications, our implementation with the advance until idle is is practical, but the Android team actually recommend using Turbine. And also when we are using Turbine, we have to now await for these states, these different states, idle, success, loading, and all that. So since they recommend we use Turbine for our production applications, we're going to implement that. But before we move on to that, we remember that ViewModel scope runs on dispatcher's main, and dispatcher's main is tied to the Android UI thread. But now we're working on our unit test, so we don't want any of those dependencies. So now we're going to add another class, which is going to be main dispatcher rule, to tell the dispatcher that once the ViewModel requests for the dispatcher main, it should give supply a test dispatcher instead. So like a mock dispatcher, just the way we use our fake repository here. So that's what we're going to do, so that once that dispatcher rule, main dispatcher rule, actually sets the test dispatcher, we can read the appropriate state. Then Turbine can now wait and collect the actual states as they come. So that is what we're going to do now. So to do that, first of all, let's add some of the dependencies that we'll be needing. So I've added mock here, and I've added the JUnit UI test somewhere here. So now we are going to add test. Let's add our Turbine. So test implementation, and we add our app.cache.turbine. Okay, so Turbine, I think we have 1.2.0. Let's see which was the latest version. Did we get that? Okay, 1.2.1. all right, so let's sync that. Okay, that's synced now. So I think basically we have everything we need now. So what we'll do is to add that class here. So we add a new class, and that class, we call it main dispatcher rule. Okay, so we add that to Git, and this main dispatcher rule is going to take a variable that we call our dispatcher, which is now this test dispatcher. We set it to a standard test dispatcher. Okay, so now here is going to return the test dispatcher class like this. So I think we need to implement some members. Okay, this is actually test watcher, not dispatcher. Yeah, we're going to override function here starting. So super starting. So here is going to be dispatchers.setMain in the beginning. So and this setMain is going to take our test dispatcher to set the main dispatcher. So here we need to opt into the experimental coroutine API. Let's make that global. Got that. Put that here. Okay. So now we have another function to override, which is the finish state. So override from finished. So here is going to be our dispatchers.reset main. So after the test, we reset back to our main. So because after the test, we'll continue with building our real app, so we'll need to reset this back to the main. Okay, so that's that class that we need now. So with that, we can now update our ViewModel test. So in our ViewModel test, we're going to here after the, so in our ViewModel test, our ViewModel is going to call the test ViewModel. Let's call this out. So first of all, we need to add that the dispatcher rule. So to get that, we use @get and we set our rule like this. So now we create a val that we call our main dispatcher rule. We'll assign that to our main dispatcher rule like that class. Okay, so here we say test ViewModel.UI state.test. No, did we sync? Because the test is actually Turbine test. Did we sync the project? Yes. So why can't we say, okay, it's now on now. Okay, so it's back. So now we say in our body, we say assert equals, we pass our product UI state.idle, then we await. So now if it listens and it's idle, you need to await to check if there is any other state that will be returned. So now, because of that issue we had initially, now if we now call our ViewModel.fetchProduct, then the success or the error state will also be read without having our test failing because the coroutine have not started. So now assert equals, we say product UI state dot loading, so that it doesn't just jump into success. It returns a result showing that there is work in progress, which is waiting for the data, which will take some couple of milliseconds. So, but we don't want the user to just be staring at a blank screen and then the product list will just appear, which is not a very good user experience in my opinion. So product UI state dot success. Then after the loading state, which we can, in our UI, we can actually create some maybe circular progress indicator or linear progress indicator to show them that something is loading. So once we are, when it's success, we await again. So, but after that is success, which is what we expect. So we now cancel and ignore every other event, so we can, this is no longer necessary. So we now cancel and ignore remaining events like that because we've actually reached the states that we were expecting for this test. Okay, so if we run that again and see if that test, you see our tests pass without errors. So each of the states will be captured accordingly. This is why this dispatcher rule, so that our view model doesn't behave unexpectedly. Then we use Turbine to await the states that is going to be emitted from our view model. Okay, so now that we've done that, we could also as well do the same thing for our error, our failure states. So here we call our view model dot UI states dot test. So in our test, we assert equals, we pass our product UI state dot idle, then we await as well. Then after that, we can now call our view model, cut this and paste it here, fetch products. We don't need this guy anymore. Then this other guy, we can just cut it and reuse, edit it up here. So now once the first product is called, we call our product UI state dot loading before the error state. So assert equals product UI state dot loading, just like we did before, then await item like that. So now here we're going to, the actual value is to await item. So let's maybe put this in a new line. So here the message is going to be something went wrong. Okay, so then we can now cancel again once we have reached that state, which is the error state that we're expecting. We'll cancel and ignore all remaining event so that our test can reset cleanly. Okay, we don't want baggages here. So let's test that out and see if it's going to pass. It passed again. So this is what this is all about, and because we're working towards a production grade application, we need to use the right tools and the right dependencies to make sure that every state and every level is captured properly, so that we don't start seeing some funny behaviors from our application. So now that we've done that, we can actually update our error mapping to improve our view model error mapping, so that we don't just, something went wrong is kind of generic and it doesn't point us in any direction. So what we'll do about that is, let's add another private function here. This will return a string. I need to import. So now we're going to return when, let's pass this, and here if our app error dot network error, we should return, if it's network error, so that we can capture specific errors, we should return please check your connection and try again. Okay, so let me just copy this. So this is going to be our server error and this is going to be our unknown error. So here we'll say we are having trouble loading products right now. Okay, then the unknown error is going to be something unexpected. So if our error and network error and server error are expected, so now we're accounting for the unexpected ones. So something went wrong. So if we go to our test, emit loading when, then error when use case failed. So let's say it's network error. copy that, because if they are not the same, the test will still fail. Like now, I think if we run this test will fail. Okay, it still passes. So now we can actually replace that. So our tests have failed. Our tests have failed because the message is not reading the same. Okay, so let's find out. So now the issue is that here the error message that we're expecting on the failure path is something went wrong. But now that we've mapped this error here, it's no longer, we can't find that error. So you see, that's why that distinction is possible. So what we need to do is, instead of returning a string here, we can actually return the result, the actual result dot error dot to user message. Okay, so now that we've done that, if we test again, our test is going to pass, because actually we're looking for the network error here. Okay, so you see our test passed. So now that's why all this mapping is very important, and actually collecting the right error message because when we're implementing the full application, it could be a network error, it could be server error, it could be many other things. So that is why the way we map this is very, very important. Okay, so let's now add our compose layer and test it as well. So to test our UI, we're going to keep our UI simple and clean so that we don't overwhelm us in this test. Okay, so what we need to do is to go to our presentation here. We'll create another package here that we'll call, let's call it UI. Okay, so in this our UI, we're going to have some component. Let's add another package that we'll call components. So this is going to be our UI components package. So in this UI component package, we are going to create some composable files. First of all, since we are displaying product, we're going to have a product screen with some content. We have loading content, we have error content, all those stuff. So first of all, let's call this product screen content. Okay, so we can add that to Git, and here you will have our composable, and this is going to be form product screen content, like that. Okay, so here in our product screen content, we're going to have some parameters. First of all, we have our UI state, which is our product UI state, and also on retry, because to load the content if it fails, you can give them the option to retry, which is how we're supposed to design our app. Not once it fails, then it just stays there. Okay, so now the next one is, let's add the modifier here and assign that to modifier. So when our UI state is true, we're going to return the different states, which is product UI state dot idle. The idle state is going to return an empty unit, like that. Then the loading state, product UI state dot loading, is going to return our loading content, which we're going to create in a moment. Loading content, and let's pass our modifier. I'll assign that to modifier up here. Okay, so we can actually create that composable loading content down here. Then when it's product UI state dot success, we're going to return product. We are going to have a product list content as well that will display the list of products, and this is going to have products. I will assign that to our UI state dot product. Okay, so down here we'll also add our modifier and assign that to modifier. Then the next state is product UI state dot error. So error is going to return, we will create another component which is going to be error content. Okay, so that we're making all these components so that they can be reusable. So message equal to UI message dot message, like that. Okay, so on retry, because that's when that error is going to be on retry. retry, then we can use our modifier again. We have captured all the states. Okay, let's create this composable and create this composable as well. Okay, don't worry about that, we'll sort that out. So first of all, let's start with our loading content. So in our loading content, we are going to have, let's initialize this to modifier here. Then here we're going to have a column, and this column is going to have our modifier dot fill max size dot semantics. This semantics is is for our accessibility features, because we want the screen readers to be able to interpret what this is all about. So that's why here we're going to add a content description, so that those who are visually impaired can actually know what's on the screen they are interacting with. Okay, this is very important. Equal to loading product. Okay, so we've imported that. So now after our semantics, we can have our horizontal alignment and set our alignment to center horizontally, then add our vertical arrangement and set our arrangement dot center. Okay, so with that, we can now call our circular progress indicator, and here we can just add a text that says loading products. So let's add some modifier in case it shoots off to the screen, and we set that modifier dot padding. Let's add a top padding of, let's say, 16.dp. So I think we'll need to import, I think I've imported the wrong text here, that's why it's kicking off. Alright, so here import composable text. Okay, actually this is going to be outside the progress indicator. That's my mistake, that's why we're having issues there. Okay, so now we have our loading content that shows us our progress indicator. So now let's flesh out our error content and move all the way up. So here we're going to have message, an actual message, and that message is going to be of string type. So we can just make this on new lines. So here we're going to add another column for our error content, then add our modifier, set that to modifier dot fill max size dot padding. So here let's add like 24.dp. So here we can also add our semantics and add the content description again, and this will say sorry, an error occurred. Okay, so then after our padding, let's make it set our horizontal alignment and set it to center horizontally. Then our vertical arrangement dot center. Let's add the body of this column for our error. So first of all, we need a test, and the test is going to supply the message, so whatever error was encountered. So let's style this a little bit, and we use our material theme, because this one here we don't have any custom theme set up already, so because we're just dealing with the test. So let's use body large so that it will be obvious. Okay, so now we can add our retry button. So our button, the on click method is going to be on retry. Then we set our modifier and set the modifier to dot padding, and we set that top padding again. We set that to 16.dp. Okay, so and in the body of the button, the test will just say undo retry. So we can actually add some material theme dot color scheme dot red or dot green. So this is going to be green, should be fine, or yeah, on error, so on error color. Okay, so we set that up like that. So the next thing is to flesh out our product list content. So here we're going to use a lazy column because here we're actually displaying a list. So in this lazy column dot fill max size, then here we're going to set a content padding, and we set the padding values. We set that to 16.dp. Then we have vertical arrangement dot space by. We space each item by, let's say, 12.dp. That's not bad. So in the body, we're going to return items, a list of items. So our items, we'll assign that to products. Then the key here is going to be it.id. So each item is going to have an ID. So in the body, we're going to return a product row which we have not created, product row, and we pass our products and assign that to products. The product row, let's create another component for our product row. So why is this guy complaining? Okay, so in our component section, let's add another composable file that we'll call our product row. Sorry, this is a composable file. So our product row is going to take up some parameters, and it's going to be our product. Then let's add our famous modifier again. I don't know why it's not importing the modifier. So now we move on. So here we create a variable that we call stock test. And this stock test is going to tell us what's in stock and what's not in stock. Okay, so we say if product.inStock, then it should return in stock, or else it should return out of stock. So here we set our modifier to our modifier, and here we set it to fill the maximum width, because now we're using a card to display each product and the content. So here semantics, we have our semantics, and it will be our content description, which will assign to, let's say, dollar, and we call our product dot name first of all. Then price is going to be our product dot price, like that. Then is stock, then we add our stock test, like that. So that's going to tell the screen reader that this is what's being returned. So in our card, we're going to use a column. Let's use another column here, and in that column our modifier is going to be modifier dot padding. Let's set a padding of, like, say 16.dp, like that. So in the body of this column, we're going to have tests, and those tests is going to say, first of all, our product.name. Then let's style this a little bit, and this is material theme dot typography, so that we make a distinction between the name, the bold ones and the small ones. So this is going to be our title medium. Then let's duplicate this like in 3 places for the price. So this is going to be price, and this is going to be body medium, and this is going to be our stock test, and this is going to be body small, like that. So that's our row. So if we go back to our content, we can now, let's undo that. Okay, so this is going to be product, because it's going to return the product class. So here is why we're having that error. We are expected to name this to return the list of products. Okay, so with that error is gone. So why is this complaining? Function product content is never used. Don't worry about it. We're fine with that. Okay, so now that we've written this, we're going to create our UI entry point, which is going to be our screen entry, like the first screen for this demonstration. So here in our UI, let's add a new composable file that we're going to call product screen. Copy this. Okay, add that. So here we have our composable, and here is going to be font. Then let's paste that. So here we have our view model and our product view model. So here we're going to collect our state. So our UI state by view model dot UI state dot collect our state, like that. So we need to import the set value. So that's fine now. So now we can now call that product screen content that was complaining earlier. So our UI state is equal to our UI state. Then on retry, we can set our view model and fetch product. So it calls fetch product on retry, fetch product, like that. Okay, so that's it. So that's our UI implemented. So now let's write the test for this, for our UI. So now this is a bit different because this is going to be the instrumented test. So it has Android dependencies. So we're going to write our Android UI test in this Android test. So here we add a new class that we'll call product screen test, like that. Okay, so in this test, as usual, we set our rules. So remember that initially we have added the UI dependencies. Let's check. Did we add the compose UI test? Yeah, okay, I've added that already. So, and did we add the JUnit 4? Yes. So I think we're good to continue with our test, product screen test. So here we use @get and we set our rule, and here we create a variable that we'll call compose test rule. And because this will be looking for a device, so the compose test rule we set a mock test. So this will be create compose rule here. Okay, so now because we're not testing this in an actual device, so here let's set our test, and our test is going to be, first of all, test show loading content when UI state is loading. Okay, show loading content when UI state is loading. So here we don't need run test because it's not coroutine test now. So here we'll call our compose test rule dot set content. So here we call our product. Oh man, what have I done? So here we call our product screen content, I think. So here we say UI state equal to our product UI state dot loading. Then on retry, let's just return an empty lambda, like that. So let's try and test this and see if it's going to show loading. Okay, so our test passed. Let's see, still building. Oh, this failed. So let's see what it's telling us. I've discovered why our test failed is because here I added this anti-activity project from Android, comes with this JUnit 4 test. So but I added the actual one, which is the compose UI test. So now if we comment this out and sync our project, right? So now that we've synced our project, if we go back to our test again, run our test again, our test is going to pass. Let's give that a little time to finish up. So our test passed. It shows loading content when UI is loading. So it passed. So our first UI test passed successfully. So what are we going to test again? Let's test for show product when UI state is success, because we have tested the loading part and it works. So test function show product when UI state is success. Okay, so here we're going to need some pass our dummy data again. So let's create a variable for that. So products is equal to list of, so list of products. So here we have products, and that products, let's say the first item is our original shoes, then second item, and it's going to cost £50, and the second one is it is in stock. So let's copy that and duplicate that a few more times. So let's say we have 3 products in our list. So this is going to be 2, this is going to be 3. So this is going to be let's say heart, and the heart costs say £20 and is in stock. So the next product, let's say glasses, and glasses is £10, but it's out of stock because it's summer. People are buying shades now. Okay, so now that we've created that, let's copy this instead of doing the same thing over and over again. So set content, product screen. So but here we are this is our success state. So here we're going to pass our products like that. Okay, so now here we're going to set our compose rule, and compose rule dot on node we test, we check if shoes is there, then dot assert is displayed because when the screen is not actually called. So here we do the same thing, dot on node we test to tell us if we have those items. So heart, then assert is displayed. Then for the final one, this is going to be our glasses dot assert is displayed. Okay, so now we can run that test and see what will happen if we're lucky again, if we did the right thing. Not being lucky, it's about doing the right thing. So now you see test passed. So show products when UI state is success. So the last but not the least, we have tested all the happy parts. Let's test the sad part. Okay, not the sad part, the actual work. All right, because if every app works without issues, then I don't think developers will be needed. So this is why we are employed. So retry is let's say show retry button when UI state is error. Show retry button when UI state is error. Okay, so here let's copy that loading again, copy that, paste that here, set. So this is going to be error, and we pass the error message. So the error message is going to be please check your connection, because initially we were testing for network error, and try again. All right, so then on retry is still empty lambda. So let's call that compose rule again, compose rule dot on node to show the test that this is working. So we check for retry, which is our retry button test. Okay, so assert display. So now if we test that bit, let's see if our error is working as well. Okay, so happy days. So now if we test the entire product screen test, all our tests will pass, I guess. Okay, so we have 3/3. That's success. So we are doing great here. So the next thing we can actually test for is the retry button to see if that is working as well. So here we check for phone calls on retry when retry button is clicked. Okay, so here let's copy this error that will have less to edit. All right, so here we say this is going to be the same. So but on retry we're going to say, so let's create a variable for the retry. So say var retry clicked is equal to false. Okay, so here we change the retry clicked to true because that's the behavior we expect. So everything here is still fine. So then we also say assert. First of all, we call, so here we say perform click. Okay, then let's assert that because we're not testing an actual device. So this is retry clicked. Okay, so now if we give that a quick spin, let's see what's going to happen. Okay, so our retry button also worked. So let's test all of them in unison. I like seeing greens everywhere. Okay, so it's all green. We're good to go. So that's amazing. So now we have actually implemented our unit tests and our UI tests, which is a glimpse of what is possible. So you can take this on now to any height you want to take it, because I believe this will get you on a very good start and show you how to do things properly. Okay, we have shown in our product screen, we were able to show actual retry attempts, our content descriptions by adding our semantics in order to tell screen readers that the screen readers can read out loud what each of those components are. So we've covered the accessibility part as well. So it's about the thinking in this so that you consider all possible scenarios and edge cases for your application. So until the next time, I hope you've subscribed. Please just take a few seconds to click that button there and subscribe, please, and share with your friends, and just drop your thoughts about this. Is there anything I believe there is a lot we can make better, and your thoughts will be very much appreciated. And share with people so that other people can also see this video and benefit just like you. Okay, then on the next one, stay safe. I'll see you again. Bye bye.